Slide 1. In the name of God, the most gracious, the most merciful. Slide 2. What is artificial intelligence? Intelligence is built from behavior and thought. A text that lacks meaning, result, or explanation is not intelligent due to the absence of necessary thought, even if it is written by a child who is considered intelligent. Walking, eating, and physical activity of an Alzheimer's patient that does not follow a purposeful outcome is not intelligent due to the lack of proper behavior. Thus, the two dimensions of behavior and thought define the intelligence of a human or any intelligent being. But this is not the only dimension. Another dimension is loyalty and adherence to human behavior. If entity A claims that currency fluctuations are directly related to the seasonal migration of birds, and entity B relates currency fluctuations to regional developments, you consider entity B intelligent because it is closer to human thought, even though the correct analysis might come from entity A. Every sane being knows that killing animals is against intelligent behavior, but a being that prevents the killing of animals, causing a shortage of food for humans, is not considered intelligent. What defines intelligent behavior is based on human thought, philosophy, and perspective, and adherence to it defines intelligence for us. Slide 3. Human-like performance, the Turing Test approach. Alan Turing introduced a test for human-like machine performance, considering 4 main factors for deeming a respondent intelligent. In this test, a human questioner asks the respondent several written questions. If the received answers cannot determine whether the respondent is human or an intelligent entity, the intelligent entity is considered successful and intelligent in the Turing test. The components of the Turing test are: natural language processing. The machine must correctly understand and process human natural language with all its rules, phonetic ambiguities, lexical similarities, and linguistic requirements. Knowledge representation. The machine must have a structure to store received questions according to its reasoning method to easily reach appropriate answers with its previous knowledge. Automated reasoning. The machine needs reasoning to conclude. Machine learning. To adapt to new conditions, find patterns, and provide appropriate answers. In the complete Turing test, computer vision and robotics knowledge were introduced to add understanding of the real world for greater intelligence and intelligent behavior to artificial intelligence. The point to note is that to build a good airplane for flight, we are not looking for a machine that flies exactly like a pigeon and can deceive other pigeons. Therefore, studying the fundamental principles of intelligence is more reasonable than spending time passing the Turing test. Slide 4. Human-like thinking, the cognitive modeling approach. There are 3 methods to understand brain function: introspection, meaning trying to understand our thoughts; observing humans during operations and thinking, which requires psychological experiments and experiences; imaging the brain during thinking and activity. With these 3 methods and the correspondence of their output with the computer system, if we can achieve good results, we can convert it into a computer model and create an intelligent entity. The General Problem Solver, GPS, was a program whose creators, Newell and Simon, did not believe in its correct execution of problems but only in matching problem solving with human reasoning. Here, the field of cognitive sciences is introduced, a field that combines computer models from artificial intelligence and experimental techniques from psychology to make the human mind testable. Slide 5. Aristotle, the Greek philosopher, explained the secret of correct thinking based on irrefutable reasoning processes. In it, with reasoning patterns, every correct premise leads to a correct conclusion. Socrates is a human, humans die, so Socrates will die. This is an example of mental operations based on logic. In 1965, logicians were able to solve any solvable problem, provided it was described in logical notation. Unfortunately, the world rarely has certainty. Logical notation applies to chess, which has specific rules, but there is no logical plan for how to roll a 6 on a die. Probability theory fills this gap and allows precise reasoning with uncertain information. This theory makes it possible to build a comprehensive model of rational thinking that leads to understanding how the world works and predicting the future using raw perceptual information. Slide 6. Rational action, the intelligent agent approach. What is an intelligent agent? An intelligent agent is an entity that provides the correct result or the best result in case of uncertainty. An intelligent agent has two advantages. Firstly, it follows the laws of thought, which emphasize correct inferences. For example, you do not put your hand in the fire. This is based on the laws of thought and your inference from the result of burning. Secondly, the intelligent agent is more aligned with scientific development and acts more harmoniously with scientific progress. For these reasons, throughout history, the intelligent agent approach has been preferred in artificial intelligence. Artificial intelligence emphasizes studying and building agents that do the right things. The intelligent agent follows the right actions like a standard model. A controller reduces costs, a policy maximizes rewards, in statistics, a decision rule minimizes loss, and in economics, a decision-maker increases productivity and maximizes social welfare, all examples of right actions. Slide 7. Utility machines. The standard model in utility machines means giving them a specific goal. However, following the standard model is not always possible for several reasons. Firstly, the goal is not always clear from the beginning, and changing the goal based on events is very natural. For example, you intend to make hot chocolate at 2 a.m. in a student dormitory, but you find out there is no milk in the fridge, and it is impossible to buy milk. This is where your goal changes to drinking tea or coffee. Secondly, alignment of quantity with the goal must be done. In the previous example, there is milk in the fridge, but it is expired. Is achieving hot chocolate with possible poisoning or death preferable to drinking tea or coffee? Thirdly, achieving the goal does not always result in the correct outcome. In the previous example, there is milk in the fridge, but it belongs to another student or a dropout student. Still, achieving the goal of hot chocolate is correct. From the given examples, we conclude that the standard model needs formulation and control, and for this purpose, the machine's unawareness of the final goal and evaluating and giving goals step by step makes the machine act cautiously and be more useful. Slide 8. Thank you very much for your time. I hope you choose me, AI Commander Alireza Khoshzaban, as a good guide on your path.